everyone. Welcome to PV Magazine's Roundtables USA program. I'm Erica Johnson, managing editor at PV Magazine, and your moderator for today's event. We are now diving into our Advanced Technologies program, where we are taking a look at the U.S. storage market and the lessons that it can learn from solar as the fast growth U.S. battery market moves towards greater maturity. This will be followed by a dialogue surrounding the very quick-moving trend among PV manufacturers where cells and largers are both going large and the continuous drive to bring down LCOE. But with there being many implications across the solar supply chain, many changes are needed to accommodate this larger future. Is bigger necessarily better?
Well, this is the question that keeps coming up, and we will be bringing in the experts to discuss this throughout the session. Hello, everyone, also from my side, and thanks for zooming in again. I'm Marian Veloun, editor with PV Magazine's global editorial outfit, and it's my pleasure to welcome you here today. A special thanks also to our platinum sponsors, Trimark Associates and DuPont Photovoltaic Solutions, and all of our partners, really, that have made our Roundtable USA possible. Also, please be advised we have a virtual event space, and you can open that on multiple browser tabs to take full advantage of the program that we have been putting together for you. If you have any tech questions and need support, we have an info booth, and you should be able to get help there in no time. And I do want to encourage you to submit your questions on our platform throughout the entire program, and we will feed them to our experts during the program. You can also upvote the questions of your fellow attendees. Please do so. And I want to remind you that we have plenty of opportunity organized for you to speak to the experts later. After this roundtable session, there will be a meet the speaker opportunity here on the main stage. Well, up now, our storage session.
The U.S. solar market is making significant progress and growing rapidly. And as we move into a more sustainable future, the marriage of solar plus storage will become even stronger in the years to come. Opening up our solar plus storage discussion, IH Markets' Julian Jansen, who leads the energy storage market research for independent analysts, is here to talk about the U.S. storage market, where it's been and also where it's going. Julian, I'd like to welcome you to the program.
Yeah, thank you so much, Erica, and great to be part of this. So I'm going to just do a very brief quick-fire presentation around what's happening in the energy storage industry in the US, how it's linking with the increasing growth of hybrid solar plus storage projects, as well as what the long-term trajectory will look like. So before I get started with that, though, we can't really have a presentation around setting the scene without talking about COVID-19. And, unfortunately, this really has been with us the entire year. But fundamentally, for the energy storage industry, it's actually not as negative as it has been for most other economic sectors. Because actually what we've seen here at IHS Markit is that strong market fundamentals keep driving long-term growth in the industry. And we've actually been revising our forecast upwards, contrary to what most people would have been expecting at the start of this pandemic. There have been some short-term disruptions, project delays, and there has been a more severe impact, in particular in the behind-the-meter segment. So for commercial and industrial storage applications, where businesses are less likely to invest into storage, into high capex investment at a time of uncertainty. But on the front of the meter side, strong market fundamentals keep driving growth. And when we look at the project pipeline, this is really highlighted in the numbers as well. So what you can see on this slide is just a brief summary of what we see in terms of the US hybrid solar plus storage project pipeline. It's really important. There's, of course, more growth that we're expecting across other segments. But when we look in particular at the solar and storage opportunity over the coming 3 years, what we see is around 15 gigawatts of utility scale solar paired with around 8 gigawatts of utility scale energy storage to be deployed to 2023. After that mark in 2023, based on the current trajectory and the expiration of the ITC, we do expect a drop-off in the market. But until then, really rapid growth as project developers are trying to capture the benefits of the investment tax credit for solar plus storage projects. So what is driving that rapid growth outside of the ITC? I've just mentioned that that is, of course, a critical driver, reducing the initial capex investment required. But on top of that, we're seeing that state mandates, especially in those states that have energy storage mandates and renewable portfolio standards, there's a clear incentives to basically kill two birds with one stone and drive out renewables plus storage projects in the long term and try and meet those targets and hit those targets respectively. At the same time, we're seeing utilities really looking for firm renewables. So interest in energy storage to help firm up renewables to basically replace new gas-built capacity, and especially also filling the gap as other thermal plants are retired over the coming years. But of course, there's some economic drivers as well around cost synergies, so particularly around shared inverters, shared point of interconnections, as well as operational synergies in terms of recapturing the clipped energy, especially for projects that are oversized on the DC end. But of course, when we look at the US energy storage sector, we need to look beyond just solar plus storage, and we need to look at the wider opportunity. So what I've just briefly outlined on this slide is how do we get, or what is driving the demand of a total of 140 gigawatts of battery energy storage projects cumulatively installed by 2050. And really we're seeing this evolution away from those near-term drivers where it's incentive-driven and niche markets around ancillary services, more and more driven by these midterm drivers where we're looking at peaker replacement, clean portfolios, and transmission and distribution enhancement. But in the long term, there remains this fundamental need for low carbon capacity and flexibility in the electricity grid as net load fluctuations caused by intermittent renewables become more severe. And at the same time, we're seeing the retirement of conventional thermal assets that are to date providing that baseload capacity. And really what we're seeing therefore is this spur for emission-free resources capable of meeting peak demand across key territories in the United States, of course, led initially by the California market. But both those roles, in terms of meeting peak demand and being low carbon, battery energy storage excels at, and as such is really a crucial part of the energy transition, helping to meet clean peak demand over the coming decades.
Great. Thank you so much, Julian, for joining us and providing this overview. It's really nice to see and exciting to see where the market is headed as well. So I really appreciate your time today.
Absolutely. Thank you.
The world looks to the United States as a leading storage market for us to learn from. While an essential part of a clean energy transition, its fast run to adoption must be executed reliably. Next up, we're bringing in the experts to discuss the battery energy storage market's move to greater maturity. While the solar PV industry can look back on decades of deployment and experience, and thus has come a long way as an established technology industry, battery energy storage is really still coming of age. In most of the world, storage is really still in its nascent stages, and the technology's adoption has been stepped out of infancy in just a few markets. With continuous and rapid advancement of the technology, we expect this to change rather quickly. But there have not been any reports of solar panels exploding to date that I'm aware of. And things can tend to go wrong when they go too quickly. It's essential that solar PV and battery storage evolve together, that our industry gets it right, that we avoid risk, and that we retain trust. There's a lot that storage can learn from solar, and in this session, we're going to explore. Now, let's get to our experts.
Well, looking at the US as a whole country, California is really leading the pack in terms of market maturity. Of the 85 gigawatts that are currently installed, of PV that are currently installed across the US, more than 28 gigawatts are located in California. That is according to National Industry Association, SEIA. And the picture is really looking similar when it comes to storage deployment. California independent system operator CAISO is counting 503 megawatt hours of utility scale storage capacity in its zone. Just for comparison, the next biggest regulatory zone in the US in terms of deployed storage capacity is the PJM territory on the east coast around Pennsylvania with 176 megawatt hours installed capacity. Those numbers come from the US Energy Information Administration. Now, introducing a new power technology is quite an achievement. And after California has already done it once with solar PV, maybe there are shortcuts to be made for storage. Bernadette Del Chiaro is the Executive Director of California Solar and Storage Association and our first panelist today. Bernadette, which lessons can be learned from the state's solar industry?
Hi, good morning. Thank you so much for having me on. I'm coming to you from Sacramento, California, and it's really great to be here representing the 600 companies working here in California on building out the distributed local solar and energy storage market. So I've got a few slides to show for you today. And I want to highlight actually some of the data that CalISO and other energy information agencies have really oftentimes exclude the behind the meter market. And so California actually has over 1,000 megawatt hours of energy storage already built today across over 500 systems, in addition to the in front of the meter market numbers that you shared earlier. So this is something we're constantly contending with to make sure that our energy regulators and grid operators represent and capture all of the values, including the energy capacity that is already installed. So I have a couple of slides here I'm going to walk you through on the state of the behind the meter solar and storage market in California today, and really highlight what I think is really the number one risk. I thought Erica mentioned important ones about safety and customer adoption and getting comfortable with a new technology. But I would say the greatest risk is in assuming that markets will continue to grow smoothly and seamlessly, and that customer demand will always be there without the proper policy supports to support the market. So with that, here are a couple of slides. This one is one of my favorite because it really shows quite astonishingly the growth in the early years, the first 7 years of the California rooftop solar market. And as it appears, the California behind the meter energy storage market. So if I could just draw your attention, these two charts, one is 2003 to 2009, the first 7 years of local PV, and then the first 7 years of local batteries, which means we've got, and it reflects about 500 megawatts. So hence that 1,000 megawatt hours of energy storage built in the first 7 years, which is very similar to the growth that we saw on behind the meter rooftop solar in California. And of course, we're all familiar, many of us, with a chart like this that just shows the orange line, the decline of the cost of PV, which is, of course, our biggest barrier for adoption of energy storage as well as solar, is getting that cost down. The orange line shows how we were able to drive down prices while at the same time ramping up demand in the product. And again, those first 7 years highlighted really shows you how we're just at the beginning stages of building out the California energy storage market. And so really the key question for us here at CalSA is how do we get up above the roughly 12% on average attachment rate? We're building over 150 PV rooftops every year. Over 400 of these systems are going in every day in California. And right now, only about 12%. Some companies are reporting up to 20% attachment rate, but it's still pretty nascent. And it's our goal, of course, to get that attachment rate up to above 90% as quickly as we possibly can. So policy really drives our markets here in California. These are mostly local policies with one exception. I'm just going to walk you through the differences that the PV market had after their first 7 years versus what the storage market has today, and just really highlight the need to focus on policy support. So 10 years ago, the PV market had a net energy metering mandate. Of course, it was for 5% of a utility's load. And at that time, we were less than 1%. So we had a long ramp on net metering. Today, there is no actual secured guaranteed net metering program. We do have net metering now, although the Public Utilities Commission is slated to revisit it again this year, in 2021. And of course, it will be a big, very political fight to protect the right of consumers to self-generate and self-store their own energy and get credits for what sets back onto the grid. 10 years ago, we had a $3 billion 10-year guaranteed rebate program for PV. Today, the California Self-Generation Incentive Program, SGIP, is likely to be fully subscribed at the end, or almost fully subscribed at the end of 2021. Subscribed in our PG&E territory, which is the largest utility territory, and maybe a few years left on the other 2 territories in the state. So really a sunset on rebates, direct rebates to consumers. This is both commercial, industrial, government, and residential, by the way. 10 years ago, we had a 30% ITC guaranteed for 10 years. Of course, we're looking at a sunset of the American ITC, US ITC, and working really hard to make sure Congress renews it, but that is an uncertain future. 10 years ago, there were no fixed charges applied to consumers in California, and today there's a $10 fixed charge. And then the last 2, I'll go through quickly. These ones are actually where there is some similarity, and where I would argue a lot of people are resting a lot of their hopes in the market growth on. One is that peak electricity prices overlapped 10 years ago quite well with solar output. Solar generated electricity and generated surplus electricity exactly when the grid needed it in the hot afternoon. That's still the case, but now we're also seeing peak rates shift into the evening to cover the evening peak, and those prices do overlap nicely with energy storage. There was strong public demand 10 years ago as California was still reeling from the Enron and the blackouts crisis of 2000 and 2001. And today, fast forward, we've got a new crisis with blackouts and wildfires and utility bankruptcies that have left consumers really wanting a different way to generate energy. And so those are strong. However, we believe we still need to really secure these 4 pieces of the puzzle to make sure that we see that nice, healthy growth curve and cost reduction for energy storage, and really truly build that clean energy future reliably and safely that we all want to build. And so last but not least, I'll leave you with this. Again, my version of risk is to ignore the need for public policy to support emerging and new clean energy markets, and to assume that public support is enough to drive mainstream adoption of these technologies. I think public enthusiasm for energy storage is going to get us to some of those early adopters that we saw in the early years of the PV market, but they won't be enough to get us into the mainstream market where economics and reliability and safety and security reign supreme. So with that, I will turn it back over to you guys and look forward to the Q&A. Thank you again for having me.
Thank you, Bernadette, for being with us and being on the program today. And I'm sure our audience will be eager to discuss the points that you just presented here, and we'll be bringing you back to the dialogue shortly. And viewers, please do raise your questions to Bernadette and all of our following panelists as we will be getting to them later in the program. Now, we all have heard about flexibility and adaptability being the key features that are needed in a variable power production system. And those systems can only be attained by meticulous real-world time control of the assets and how they respond to shifts in the power supply. Utilities and system operators, they are the ones who make these decisions and who need to communicate with storage assets and all assets really. And with the market being awash with products, a standardized system communication has become a critical task to develop. Our next panelist has joined the mission to develop and introduce an open, non-proprietary communication standard for storage systems. Trimark Associates VP of Technology and Development is Bory Akyol, and he will explain to us how adopting standards and will streamline the integration of energy storage systems. Hi, Bory.
Hi.
Thanks for being with us today.
Hello. Oh, I'm glad to be here, and I'm happy to speak about how open, interoperable communication advances the storage industry and minimizes deployment risk for these very large budget, very large scale projects. Great. So I'm going to just go through a few slides today. If you have any questions, please type them up in the Q&A or chat window, and I'm happy to answer them towards the end of the session. So I'm going to speak about Modular Energy Storage Association and the work that they're doing for open standards for energy storage and integration of energy storage with other renewable assets. What you see on the screen here is a set of members. Mesa has been in existence for quite a while, and they have deployed two sets of specifications. One is Mesa DER, which focuses specifically on the communication between utilities and the energy storage control assets that perform that real-time control that was mentioned a moment ago. And the second set is the Mesa device specification working with SunSpec, which is focused on how we communicate inside the plant. And these are both equally important, as I mentioned, to reduce deployment risk in a large-scale project. A utility-scale energy storage project, as the ones that we have seen recently announced, runs easily into hundreds of millions of dollars, and it can contain hundreds of megawatts and 4 to 5 hour energy storage. So this is a large system. With that, you want to make sure that you have components in there that implement open interoperable standards so that you can deploy them with minimal risk. They are well tested. And if something fails, you can swap them out with some other brand equipment if you wanted to. And that's what Mesa has been working with member utilities, member vendors, and as well as national laboratories that are members of Mesa. As I mentioned, without standards, this could be a risky transition. If you imagine that in a typical, if you look at California ISO, I believe in the queue right now, in the interconnection queue, request queue, there's 29 gigawatts of energy storage plus PV combined plants. And if you think about that, and if we didn't have an open interoperable standard and every plant did something different, it would be very difficult for us to integrate that into the grid and how we control these plants with the existing grid operations. Mesa standards specifically reduce risk because they reduce the time required for DERs to come online. They are much more approachable to those entering the market. They make it easier for new entrants to come into the market and integrate with the existing grid controls. And they require both semantics of what is being communicated to be standardized so that if you're communicating a control point, that not only the name is the same and its address the same, but it is implemented in the same way. They also specify the control operations that need to be performed, such as frequency support, voltage support, or battery state of charge management. So my recommendation here, if I could get on a little bit of a soapbox, is that utilities and ISOs that are procuring power from these plants that are being built by developers, more than likely, must insist on standards to make the transition easier. And they are perfectly positioned because at the end of the day, they're the off-takers or they're the reliability entity, and they can basically just ask for it. And in certain cases, they can mandate them as part of their procurement process. And this is nothing new. For example, in California ISO has for a long time had remote intelligent gateways, which you can see one of the Trimark ones here, that implement a specific way for CAISO to control the plant for telemetry and also automated dispatch. They have mandated approved meters so that we get accurate information. And they also mandate reliability and capacity requirements. So what I'm saying is that the utilities and the reliability entities and ISOs should really ask the developers and the control vendors to implement open standards-based controls so that we have a level playing field and that the components are interchangeable. I will close with this. If you look at the consumer electronics space, if you bring a Wi-Fi device into your home, you're not really looking for that Wi-Fi device to be certified to work with that particular router, right? You're working with a standard Wi-Fi, a certification which is done by the Wi-Fi Forum, and they just work. The same thing happens with USB. You basically, everybody certifies to a common standard, and you plug it into your computer, 99.9% of the time, it works. Energy storage controls, in my opinion, should strive for this type of structure dependability. One of the things that I skipped over in a previous slide is that we're going to see the storage market evolve, where I believe the battery manufacturers are going to start offering products that are more integrated, which I would call a DC block. And to be able to integrate these DC blocks from any vendor, you want to have an open standards-based interface between the DC block and the control logic that's implementing it, as well as the inverters. So there are really good reasons why we should apply an industry-wide adoption of open standards. And one last thing, if you have equipment that works the same regardless of who made it, it is controlled the same regardless of who implemented the control logic, it also simplifies workforce training, especially in the US, when we have a turnover of staff that is very experienced, but unfortunately reaching retirement age, and we're trying to bring new staff online. And that is really important point to focus as well. If you have any questions, my email information is right there. I'm happy to engage either in real time or offline communication about these topics. Thank you very much.
Well, thank you, Bora, for this interesting kickoff into the debate of system integration, and we're surely we're forward-looking to bring you back to the Q&A session with the other panelists later. Well, now, reports of solar and storage undercutting the cost of fossil fuel rivals are always a guaranteed cheer in the offices of solar companies. Well, however, where price pressure is mounting, there is a lingering danger of drops in manufacturing quality. The PV sector knows this all too well. But for modules, the problem could largely be handled with third-party factory audits. Buyers of modules would demand a score from an auditing service provider for their proposed module supplier. A good score should leave investors rest assured that the investment is unlikely to become a high-risk liability. One company that has been in the business of providing such factory audits for modules has now expanded this approach to battery manufacturing. Photovoltaic Institute Berlin, or as you may also know them as PI Berlin, has devised a methodology to benchmark the over 170 processes that go into the making of a battery. It is my pleasure to welcome Ian Gregory, Managing Director of PI Berlin's North America division, to the panel. Hello, Ian.
Good afternoon. Thank you very much for the invitation to join you today, and welcome from the East Coast, Boston, up here in the Northeast. There was a talk at the beginning, right at the beginning, about the importance of maturity in the energy storage industry, and reference to how we get there through growth from the first presenter and through standards from the second presenter. Now we'll turn our focus towards quality and how audits of battery factories can help understand the quality of the battery and help to mitigate energy storage project risk. So to kick off, just briefly, what do we see as major concerns with batteries today? The most important, and perhaps not surprising, is that batteries are, of course, a critical component in any energy storage system. The energy storage system is only going to perform as good as the battery that's installed within it, and potentially represents the greatest risk to safety within the storage system. Battery design is very complex. Batteries look like a black box from the outside, but inside they're very complex. Which means there are many parts within a battery and within the process to make it that can hide quality problems. And battery technology is changing rapidly, which is a good thing. But on the other hand, change always represents a risk to quality. Anytime something is changing in a factory or in a product design, it takes effort and focus to manage quality. Secondly, the quality of the battery can impact its safety, performance, and reliability. There's perhaps a statement of the obvious, but it does mean that looking behind the scenes to understand exactly how the batteries are manufactured is very important to understand how good they may perform in the field. And lastly, we do see a dramatic proliferation in the number of battery suppliers and manufacturers out there. A lot of new entrants coming in from Asia, and many instances low-cost batteries that are obviously very tempting for many developers, utilities to use, but may well come with concerns or questions about quality. As PI Berlin, one of the major activities we undertake on behalf of a wide range of downstream clients in the industry is conducting deep dive assessments of the manufacturing processes behind batteries. That really means an in-factory, boots-on-the-ground type of review of all the operations behind assembling a battery, right from the initial chemicals and basic materials right through to the finished product. And those assessments typically produce highly actionable findings that allow a project developer, an integrator, an EPC, a utility, whoever you are, to take those findings and work with the manufacturer to mitigate those risks before you start deploying the batteries in your systems. The benefit of looking at the battery itself as distinct from the rest of the storage system is that once you've looked at that battery, wherever you deploy that same battery in other systems, you can leverage that same knowledge about the quality of the battery you're dealing with. The battery manufacturing process maybe was a surprise to me when I first started learning about how batteries are assembled, but they're very complex, over 170 processes involved in many different materials. Purity is important, homogeneity is important, quality checks throughout the process are extremely important. So it's a complex process to audit and really requires a very structured, thoughtful, detailed step-by-step analysis to understand where poor quality might be hiding within that battery that you need to know about. And lastly, as a product of the assessments that are done, one of the things we produce are quality ratings. So literally, from the worst to the best, how does the quality of one battery stack up against another? And that's particularly helpful for clients who are maybe considering a wide range of batteries, or an increasingly wide range of batteries. Help them determine which batteries are worth exploring, which batteries are worth using, or tell somebody, if you're choosing a particular type of battery or supplier of battery, what work may be needed in order to get that battery to the standard you expect to see in the system you're deploying. So that's just a quick overview of the quality angle on batteries and energy and storage, and we see this as certainly an area that's going to and is growing in importance within the industry, along with standards, as the gentleman from Mesa mentioned. The two really go hand in hand. Thank you.
Thank you very much, Ian. Now, let's step into our last presentation before bringing you back for the Q&A session with the audience questions. And let me remind you, viewers, that you have the chance to forward your questions, and the experts, including Ian, will be in the position to answer them just after our next panelist's introduction. We all have heard the cries of the naysayers. Solar needs more flexibility, as cloud cover or nightfall might interrupt supply. Battery storage has been proposed as an easy fix to this. But there are many tasks that storage can take on which are not time shifts. Batteries are really not one-trick ponies. A new set of skills, however, is required to planning such assets. A plethora of technologies is on the market, and there are numerous value streams which can be stacked up on each other. Customized storage solutions are the proposed solution, or there's not one solution that fits all, but there's really a combination of many different decisions that can be made. One of the largest solar and storage developers of this nation, 8-Minute Solar Energy, has a considerable pipeline of solar and storage assets. The company's VP of Engineering, Emily Arnold, has joined us today to share her insights that 8-Minute has gained in making technology choices, assessing risk profiles, and designing new solar plus storage arrays. Hi, Emily. Thanks for joining us.
Hi, everyone. Thank you for the time. As mentioned, I'm Emily Arnold, and I'm excited to be here talking about how PV developers have changed to really adapt to PV plus storage hybrid plants. As mentioned, don't want to spend any time here. Just wanted to note that 8-Minute is, a large-scale utility PV plus storage in the United States. Developer that has really shifted from the history of their PV development. So we've handled, kind of this transition real time, and as the industry starts to grow, really have been focused on, this shift in the market. Really when we talk about this shift, I wanted to dive right into, what really is the challenges at hand and what's really changed from the PV market. When we were looking at PV only projects, it really was, you were guaranteeing energy. You were basically selling a product of energy when the sun was shining, with some minimal guarantee over annual or 2-year period. And really the shift to PV plus storage has added a lot of flexibility, but has also shifted the dynamic of what product you're selling. Not selling a one-size-fits-all energy product, you're now selling grid stability, transmission avoidance, ancillary services in a way that needs to be off-taker and project specific. So initially when we shifted to this design to off-taker needs, you saw a lot of off-takers that just didn't exactly know what they wanted. They wanted full flexibility, and that was what they valued, over the full term of the PPA. And, this was really not attainable for developers. It was expensive. There's no technical bounds and, massive risks around the PPAs. It was just hard to design around. Instead, now there's been a drastic shift to moving the market towards not full flexibility, but having flexibility that is specific to what the off-taker is looking for, and really aiming your design and innovation of your product to those off-taker needs. Obviously, with this as a developer, this comes with new responsibilities and challenges, not only from the developer standpoint, but the long-term owner of the project, just because there's more flexibility and more obligation within the PPAs. But also there comes technical challenges around how quickly the technology is advancing, as well as there being no industry standards around modeling and performance of such tech. So tried to really group, where PV plus storage developers have really leveraged, not only their PV experience, but kind of the push to bring PV plus storage to market in a meaningful way, really link this down to kind of both commercial and technical parameters. There's the contracting aspect, there's the technology aspect, there's modeling and performance. So from a contracting perspective, really the big swing here is that there's been a lot of education that's had to go on in the industry. As a developer, we're now focused on ensuring that, off-takers understand both the capabilities and advantages of storage, but also the limitations of the product they have, so that there isn't obligations in the PPA that are unattainable. The battery OEMs and manufacturers, educating them really about, what diligence goes into their product, and, as they move their tech along, how do we really holistically look at their technology in a robust way, as well as education to the financing parties. And so really this contracting swing has moved, what used to be somewhat technical, but much more of a commercial conversation, to a very highly technical discussion through PPA negotiations, as well as contracting of the equipment suppliers, the integrators, and the controls providers, as Bory mentioned. Additionally, as our last gentleman mentioned, the technology is moving really, really fast. In the solar world, we obviously saw technology changes, and being technology agnostic was basically key to how the industry thrived. We wanted the flexibility to be able to leverage new technology as it came on, but we had to do it in a really thoughtful and meaningful way, and really take those technology leaps to 1500 volt and bifacial and new suppliers in a data-driven analysis and deep due diligence approach, which is really the same. Our view is from a technical perspective on the storage side, we want to understand the manufacturing, the quality, the testing, and really want to do a deep dive on bankability and diligence as part of technology selection. You can't just pick the cheapest technology because we're not looking at just a quick fix. We're looking at the lifetime of the project and through the PPA term. The other aspects that are really key as a developer to be focused in on is the modeling and performance, which go kind of hand in hand. On the modeling side, unlike the PV world, developers have really had to shift. There was no industry standard storage modeling tool, and especially none in a way that had the flexibility and customizability to what we were seeing the market demand. So a lot of developers have devoted time and resource to really build out their own modeling tools to capture the performance aspects of the plant as a whole and really optimize around not just a PV with storage stacked on, but PV plus storage hybrid plants together, looking at new layers such as augmentation, but as well as the technical parameters of both the PV plus storage operating together. The last piece I wanted to emphasize was just around performance. This is a piece that the industry is new at the scale that we're at, and it's really critical to making the ability for PV plus storage projects to really make a splash in the industry. So while industry best practices are still getting built out, safety becomes a #1 priority, and having deep technical expertise and emphasis on both testing and use case specific applications around the project performance become pretty critical to how we think about how the product will operate long term. So with that, really enjoyed the time and definitely look forward to any questions you guys may have.
Well, thank you, Emily. Our audience, thank you for kicking us off into this direction and giving the developer perspective on this topic. Now, let's bring back our other panelists and Erica for a Q&A with the audience. Well, thank you for joining again, Erica, and of course, Bernadette, Bora, and Ian. Thank you for being here again. Erica, you have been watching our online community throughout this time. What's on their mind?
Yeah, actually, we have a lot of activity going on. I'll go ahead and get started in order of the speakers. Bernadette, question coming in that I know has been frequently brought up among us as well is surrounding virtual power plants. And when do you see this coming up soon, and when do you think it's likely to happen, and will there be incentives available to make something like this happen?
$1 million question and an excellent one. The wildfires and the blackouts of August 14th and 15th of this past year have really helped to elevate the potential for distributed storage systems to contribute to California's peak grid energy needs. And so we are seeing a bit of an uptick in interest among our state energy regulators. There's in fact a workshop happening today at the California Public Utilities Commission, and there's another one scheduled with the Cal ISO in a couple of days. And so we're hopeful that they will remove the barriers and put in place the mechanisms for our batteries, which I mentioned. There are 500 of them already installed to date across the state, totaling 1,000 gigawatt hours or megawatt hours of capacity. Most of that energy is sort of left on the table and not utilized effectively, like through a virtual power plant program. So the long and the short of it is on the table. It is up to our energy regulators to make the moves to tap into all the value that energy storage can provide California's grid. And we are hopeful that they will move, especially given the blackouts. And if not, there are, I know, interest in the California State Legislature to move that conversation along.
Thank you. Thank you.
Right, thank you. Well, virtual power plants are really those elements in the power system that require a lot of communication. So I will kick a question to Bora at this stage. Our audience members are wondering that you mentioned earlier that Cal ISO has introduced remote intelligent gateways and other standards. And they're asking, are we seeing similar trends in other regulatory zones in the US? And I do permit myself to extend that question a little bit. Would we see a federal solution at some point in the US?
That's a tricky question to answer. Yes, other ISOs are looking at standards for connecting energy storage to the grid and providing the services that Emily a minute ago mentioned. As far as federal solution, I think FERC already has recommendations and really standards on bulk power system connected resources. And I kind of see them as enough for now in terms of being able to support grid regulation and the stability of the grid. I think most of the regulation or most of the standards are related going to be at a regional level for control of these assets to fit the needs of that specific region. If a region has primarily energy markets and everything is done through market transactions, you need a different set of controls than if you're in a region, say like Washington State, where almost everything is vertically integrated utilities, and you are doing control functions where you may take a PV or wind plus energy storage plant and focus it to use or generate a baseload type shape. So unfortunately, the answer is it depends. But yes, I believe that other ISOs are already working on that. Just one clarification, remote intelligent gateway standard is for plants that are interconnected to the CAISO system, renewable energy plants, and that has been in existence for over 10 years. So it's not something that they have introduced recently. However, CAISO has been working on how to integrate hybrid PV plus storage plants into their system, and that's an activity that has been ongoing for 2+ years, and it's almost at the end where there will be a business process manual addendum for interconnecting hybrid plants into the CAISO system.
Okay. And a follow-up question to that, who is driving the MESA? Who is driving MESA? And one question that came in is it the government that's behind this, or who's working on driving this initiative forward, really?
It is not the government, although MESA did receive some government grants for the first version of these standards.
Okay.
But it is now primarily utilities, vendors, and I guess in a way, federal government, because national laboratories are involved. And the work this year and next year is focusing on compliance and certification with respect to the standards that MESA has published, either through SunSpec or another organization, so that we have, interoperability is much about compliance and certification than just having a spec where people say, oh yeah, we're good with that. You have to test. Without testing, you don't know if it complies. And that's what MESA has been focusing on. And it is funded primarily or almost 99% by membership fees.
Okay.
Well, testing. Ian, that's something that you know a thing or two about. So you have tested quite a lot of batteries, I imagine, or not you personally, but your PI Berlin organization. And what are some of the issues, of the most common issues in the processes, in the manufacturing processes that you have discovered that you can tell us? Where should we look at when buying batteries?
Yeah, good question. Actually, you raise a very important point. There are really two key components of understanding the quality of a battery. One is testing the design through testing, which is actually something we typically don't do. We're not a battery testing lab. There are a lot of labs, or a good number of labs out there doing testing on batteries. We're looking at the other component to quality, which is on the manufacturing side, is that you can have a really well-designed battery made with great materials, but you can bluntly put, screw it up in the manufacturing process. Every battery has to be made to a high standard in order for that design to function the way you expect. The biggest issues we come across are, to be honest, less related to safety at the battery level. That is always a concern, but it's more we're uncovering things in the process of making electrodes within the battery, the quality of the raw chemicals within inside, the purity of the chemicals within inside the battery itself, that can lead to underperformance of the battery in the field or long-term reliability problems. And so that's probably the number one for us is some of the quality of those incoming raw materials that make a battery, and some of the core processes to assemble the battery that can lead to underperformance. And some of those things that we found already have led to improvements that we believe will lead to improvements in performance in the field. Things that people just took for granted that would happen with batteries turn out to be things that could be resolvable.
Great, thank you for that. And then we'll go ahead and tailor one more question to Emily. Emily, what's the real impact on the cost of money when storage is added to the project compared to just solar alone?
Yeah, it's a great question. And, you know, like I said in my presentation, unfortunately, there's not one size that fits all. But
Right.
I think the real benefit here is not just what you see in dollars. I mean, obviously, it costs more to build these plants, but you're also getting these different revenue streams. And, you know, utilities are really anxious to pay for and able to pay for, you know, grid stability and certainty. And so really what you start to see is that, you know, some utilities are emphasizing higher capacity factors of a plant and willing to give you a higher PPA rate for this, or, you know, give you a capacity payment, or they're incentivizing, you know, more of these time of day rates as folks had mentioned, as the peak shifts. And particularly in California, as you start to see this duck curve, you know, you really want to leverage storage to basically maximize the output when people need it and really more closely match the demand on the grid. So we'll say that although more expensive, we're seeing, you know, our LCOE and LCOS be more beneficial significantly for PV plus storage, just because you've really expanded the capabilities of your plant overall, and utilities are valuing that significantly.
Okay, great. Thank you for that.
Thank you very much, Emily, and also thank you very much to all the other panelists for sharing your time and being here on the program today. I think our audience was surely very interested in what you had to say and to share today. Of course, there's always very little time to get through all the questions, but this is why you will be sticking around for Meet the Speaker session later on here on the main stage. So don't fret, viewers, the experts will be later on here on the stage. Well, next up, we have yet another technology, advanced technology prepared for you. It is about the bigger module future.
And we're back. Welcome to the second part of PV Magazine's Advanced Technologies Roundtable, and sadly, the last panel of the day, but fret not, we have a stacked lineup with some of the biggest players in the industry to discuss what is probably the hottest topic right now in the solar sector surrounding manufacturing and the continuous rush to bring down LCOE with large-scale solar in the US, with modules going larger. Cells and modules are trending large in what seems to be an arms race among manufacturers to increasing module output. I'm Erica Johnson, managing editor of PV Magazine and your host for today's Roundtable USA. Our platinum sponsors for this event are DuPont Photovoltaic Solutions and Trimark Associates. And now let's get on with the program. Aside from ensuring quality and reliability of solar assets, it's really all about bringing down LCOE. And now one of the biggest trends that we're seeing among manufacturers is the move towards supersized modules and cells. But first, let's take a look across the cell and module trends with Xiaoting Wang, energy specialist from Bloomberg NEF, who's zooming in with the latest trends in the market and where the upstream industry is headed. Hi, Xiaoting.
Thank you.
Nice.
Hi, Erica.
Hi, nice to see you.
Yeah, nice to see you. Should I start my presentation?
Yeah, sure. I'm really thrilled for you to be joining us. Please.
Thank you, Erica. Thanks to PV Magazine for offering me the opportunity to share BNEF research on this panel. Revolution on module size is one part of the story for PV economics improvement. And I would like to kick off this session from a bigger picture. Next slide, please. Based on historical price data of silicon PV modules over the past 45 years, we derived a learning curve indicating that module price could fall by 28.8% every time the cumulative installation doubles. Next, please. Applying that learning rate to our market forecast suggests that module price could drop by another 70% by 2050. Next, please. Boosting efficiency is a straightforward approach to lower per watt module cost. We expect the average module efficiency will come to 19.9% at the end of 2020. Starting there, relatively 67% improvement will occur over the next 30 years in 3 phases. So first, 2021 and 20 will experience engineering optimization, still based on P-type wafers and PERC cell structure, including going towards larger modules with more compact cell layout. And 2023 to 30 will be a period of transition from P-type to N-type products. And commercialization of 2-junction solar cells will be realized post-2030. And we think structure with perovskite on top of N-type silicon has the highest chance. Next, please. If the cost of making a square meter of module remains the same, improvements in efficiency can only drive down the 2050 per watt cost to 60% of the 2020 level. And we expect the unit area cost of module production will fall by 47%, which can be achieved by less consumption of materials and utility and cheaper materials and equipment. The 2 forces together will trim the per watt cost by 68% by 2050. Next, please. The economics of PV electricity is directly related to system cost, which spans a wider range for various markets, mainly caused by trade barriers and different labor costs. When predicting long-term system cost, we removed policy impact and deliberately chose China as a benchmark, as most equipment used in other countries is sourced there, and it has the most installation as a single market. Next, please. In order to better predict future trending, we looked into the cost structure of a 100 megawatt project in China with fixed tilt, grouped into 3 categories: equipment, construction and installation, and other variable spending. Next, please. To derive the impact of module efficiency to system cost, we recategorized all non-module costs based on their correlation with module efficiency. Structural costs that can be roughly considered inversely proportional to module efficiency. Electrical costs whose per watt value is not directly affected by module efficiency, while the AC part depends on inverter loading ratio. And fixed spending whose absolute value will not change as efficiency rises. So the per watt cost is also inversely proportional to module efficiency. Next one, please. So with this correlation, non-module costs will fall by about 30%, benefiting purely from module efficiency rise. Next one. Besides boosting efficiency, enlarging modules and adjusting cell layout could also lower non-module cost. So here are 2 case studies released by LONGi for its HIMO 5 and Trina for its Vertex. In LONGi's case, increasing module size by 28% can save 1.3 cents per watt for non-module cost, with the underlying principle being that the percentage increase of many costs is less than module size or power addition. And Trina claims that its Vertex of a similar size as LONGi's HIMO 5 can further trim non-module cost by 0.6 cents per watt, with a different cell-to-cell connection design that results in lower module voltage and higher current. So more modules can be arranged in a longer string, still with a system voltage at 1500 volts. The basic principle for cost reduction is similar to that for a larger module. many costs increases at a lower than linear rate as more modules are installed in the same string. Next, please. Besides passively benefiting from module innovations, non-module costs will also have at least an independent 0.5% annual reduction, with efforts by equipment manufacturers such as inverter and tracker makers, and further system optimization like raising inverter loading ratio. So if we include all the factors, the whole system cost by 2050 will be about like 53% lower than today. Next one. Translating to absolute values, so the fixed tilt EPC by 2050 will be 23 cents per watt. Next one, please. And switching to one-axis tracking will add 2.2 cents per watt on top of that in 2050. So back to the focus of our panel, bigger modules. As a third-party research organization, we agree with the fundamental logic of cutting non-module cost by enlarging modules and revising the cell stringing pattern, although it will take time and probably further design adjustment to convince the market. We will learn more from our panelists in the following discussion. So now I will hand the mic over to Erica.
Great, thanks Xiaoting. I think that this is a great way to set up our panel discussion, and please stick around to be a part of it. As you mentioned, larger and more powerful modules are a major development in the solar market, and really, who would have thought 500 watt, 600 watt, 700 watt modules be coming to the market? But is bigger better? Let's bring in the panel to discuss. Joining Xiaoting and I from Bloomberg NEF and I today, we have a star-studded industry lineup for this panel session. Thank you so much for joining us. First, I would like to introduce our module experts. Hongbin Fang is the Director of Product Marketing at Longi Solar. Thomas Kurner.
Thank you, Erica.
Hi, thank you. Thomas Kurner, Vice President of Module and System Solutions at Canadian Solar.
Thank you.
Our balance of system experts that are joining us today, Dean Solon, President and CEO of BOS Manufacturing Company Shoals Technologies Group. Hi. Colin Cowfield.
Hello, everyone.
Colin Cowfield, Vice President of Sales for North America for tracker manufacturer Soltech.
How's it going?
And George Touloupas, Director of Technology and Quality, is joining us. Thank you for joining us, guys, and welcome to the program.
Good morning.
Okay, so first I would like to get started in, we have larger modules, higher efficiencies, ultimate goal of bringing down LCOE, and I'd like to start with the advantages and cost reductions. Does it really pay off in terms of LCOE? I'd like to go ahead and kick this one over to Hongbin first.
Yes, I think industry has seen that based on Xiaoting's analysis, right? That have shown that the wafer size is increased from M2, right, 2 years ago. And we introduced M6 last year, 166 millimeter. And this year we introduced M10. So the concept is that when you increase the module size with the larger wafers, basically increase the power per string on the 1500 volt, string, which can enable, savings on the both tracker and cabling and as well as labor, right? Because the cost on the tracker cost will be increased, but not as much as the power increase. And the cabling, because the fewer strings will be required for the same number of megawatt numbers for the project. So definitely in general, I think the larger size modules will help to reduce the BOS cost and then reduce the LCOE.
Mm-hmm. And Thomas, with Canadian, are we seeing the cost reductions? Are you in agreement? It's BOS and installation costs. Where can we find all the cost savings that will be coming from this larger module future?
So Canadian Solar was the first company introducing a 166 millimeter cell-based. This was our first poly-PERC product, more than 400 watts. And these 2.5 years back, it was a unique new product. Tracker companies, BOS companies, were surprised about this trend. And the industry has started to adopt and to optimize the systems around. And I believe now Canadian Solar moving from 166 mainly to 210 millimeter format, which is a significant jump, the same process is happening. So we're seeing BOS component manufacturers redesigning their components, tracker manufacturers optimizing it. And as the Longy colleague said before, at this point, the costs of certain components may be still higher than compared to other costs we have seen so far, but the optimization is happening. The optimization will bring the overall costing down. From a product perspective, it is simply, as a manufacturer, easier to produce and to handle a larger cell at a time than a smaller one. The same process, the same step, the same deposition, you have more watts at the same time. And that's, from a manufacturer perspective, the significant and most important cost saving right there.
Okay.
So I have a quick follow-up question, Thomas. So that is actually a theoretical question, which is how much cost reduction could happen for module production if we switch from 166 to 182? I say it's theoretical because you can never get an apple-to-apple comparison, because at the same time, you can always have one product with much larger scale than the other. And when you can find 2 time slots for like the same scale for two products, some other factors happen at the same time other than module size. So that's why I call it like theoretical. But still, I think it's worth asking, as many audience could be interested in that as well.
No, you're spot on. It's an excellent question. I think we have seen the first limitations in economies of scale from a pure capacity perspective. If you have today a 20 gigawatt factory or 30 gigawatt factory on the same product, this scale has been limiting. You still have some upstream benefits on sourcing benefits, but from a pure manufacturing perspective, you are basically squeezed out. So we're looking for new opportunities and new ways to get costs further down. We have seen and proven the benefits when we switched over from an 156 millimeter cell to the 166 millimeter cell on our apples to apples comparison. So we have that as an experience and background. And we can extrapolate the 166 to the 210 millimeter switch in a similar way. Again, we have decided we're going to jump all the way up because, in our opinion, others may have different opinions, the switch to the 182 was there and we could see the apples to apples comparison, but not significant enough as it was before in history. So the largest step for us, we believe it has certain dollars per watt CapEx savings, but the most important impact is on the LCE base. And again, it's not the pure module power we're going to talk about. It's easy to produce a really, really large panel. I have produced 15 years ago a 1,000 watt panel, which was a monster and not able to move. The more important part here is...
I want to make sure that I understand this correctly. Did you say that the LCOE will be lower, but the system CapEx will not necessarily be lower? Did you say that?
No, the system CapEx will be lower. And also the opportunity for manufacturer for overall cost of goods and module CapEx is lower or can be lower.
But at this moment, like the much larger modules are sold with a price premium. So basically you are saying the saving at non-module parts can outweigh the price premium on module.
Correct. At the end, the economy and the buyer and seller relationship and balance will manage the price in the market. We're able to give a value to the market, and the market sees a certain pricing for this value. And it balances how much, say, cheaper can something be produced and what value we are generating in exchange. And at the end, of course, the value needs to be shared in a certain way.
Yeah, I'll just be noisy and ask one more question on this. Because I saw like one day from public document from JA Solar, which mentions that for 2021, like the modules based on 182 will be probably 2% more expensive than modules containing 166. Do you think that is a reasonable range, or you think probably higher or lower?
So I cannot comment on JA's numbers because it's being influenced by supply chain, where you're getting your silicon from, all the material inputs, et cetera, et cetera. It's a highly complex calculation and coming to a certain conclusion. We see that the new larger format panels would not have a higher costing, but it generates more benefit and more value. And I think the most important is, we talk about power a lot. I would like to steer the discussion more over to efficiency. Our 665 watt panels can generate up to 21.4% module efficiency. And that is one of the main driver of LCV. It's not just a sheer format, it's the efficiency which comes with it.
Thanks.
So I do want to kind of switch gears just a little bit here in the dialogue. There are obviously industry adjustments and implications. Bigger, more powerful modules will require redesign of the module, the supply chain, and in system design. So I'd like to dig a bit into this. Dean, I have a question for you. You've seen a lot of changes over the years in the junction box itself. More powerful modules require some changes there, but also with the fuses. What are the challenges with us moving towards this larger module format?
Well, first of all, thanks everybody for having me on the panel.
Thanks for being here.
Glad to see all my friends across the screen here, and thanks for the time. But from what we're seeing so far, is large format panels going to happen? Absolutely. There's no question in our mind. The one thing we're seeing right now is that the voltages are being brought down a bit, so the currents are increasing. And that's giving the strings, the EBOS strings, a little bit more taxing load. You'll go from, say, a 30 amp fuse up to, it could go to 40, 50, 60, all depends on the short circuit of the string. So right now we typically string a current system in a 3-string tracker row. We could use a 30 amp fuse. All's good. As these currents increase, we're going to have to drop down to a home run or a 2-string harness. And then these fuses are going to have larger ampacities, which is a format change again. So we're going to see some new fuses come out, some new fuse holders. Instead of using, say, a 10 millimeter square or a 10 gauge wire or 8 millimeter square wire, whatever we currently use, we could go as low as 4 or 6 gauge wire, which will increase the stringing costs. But in the end, when you look at the watts per table, per block, per whatever size you want to talk about, it's going to come down. The only thing that is in the next 6 months, we're going to have a few wars on how quick it comes out and whose format's the best. And, are the trackers ready for it? Are the inverters ready for it? Because right now we've been working with inverter players. They all have 400 amp inputs on these inverters, where we've been working with multiple sources trying to get it up to 500 amps. We might have to take it up to 600 or 700 amps per input into these inverters. So there's a lot of technologies that's going to catch this. The biggest thing I'll stress is, as it's happening, make sure it's being done reliably, because when fuses changed from 1,000 volt fuses to 1,500 volt fuses, they went from a 10 by 30 size fuse to 10 by 85. And those fuses were not really reliable at the time and caused a lot of people a lot of stress in their fields from fuses just blowing for no reason. We got to make sure when we go to this new format that these fuses are truly reliable, because you could have the best formats in the sunniest days, and when fuses are popping because they haven't been properly tested for reliability, you're going to generate no power.
Yeah. So speaking of trackers as well, trackers are literally going to be bearing the weight of these new modules. How difficult, Colin, is it going to be for heavier modules for tracker structures over the long term?
Long term. Well, at first, much like Dean had mentioned, thank you so much for having me, guys. It really gives me a good opportunity to get out here and speak to some of the products that we have that were being released onto the market also. So to that end, these changes to the modules come at a really opportune time for Soltech, because we just released our SF8 product, which is geared specifically towards these larger format modules. So the focus for us has been looking at how can we make sure that we're still providing our customer with the strongest, most robust, most reliable system that can withstand not only the weight of the modules, but also a variety of different pressures that they're going to experience in different conditions, while not compromising on price, right? And I guess what I mean by that, to echo some of the things that Thomas and Hongbin had mentioned, the unit price per tracker may be affected and it may actually go up, but that's actually not a bad thing for the LCOE, because we're going to be hosting so many more modules, and our tracker is going to be, I guess, configured or designed such that we have so many fewer screw connections per module, and it's so much more efficient to be installed. So the efficiency is really the name of the game there. And as Thomas had mentioned, the CapEx will actually end up going down for the overall plant, because you'll need so many fewer trackers to achieve the same level of production than we did before. And the other major focus that we've had has been around increasing the production that you can have in given conditions with our product, or using the influences that we can on our design to maximize that. So that has come in the way of algorithms that we've been working on, that we've had third-party verifications on, as well as some other design features for the bifacial features of the modules, so that we're really maximizing how productive they are. So again, it's been a really opportune moment for Soltech, being that we were already releasing a new product, and we can make sure that the customer really is the one who ends up benefiting from the lower cost of install, lower cost overall CapEx, and the increase in the yield on the plant.
Great, thank you. Yeah, a lot of adjustments and modifications that are being needed across the industry. Now, on the manufacturing design of things, there's somewhat of a seem that there's a split between those who view the bigger jump to the power output enabled by 210 millimeter wafer as a goal worth pursuing immediately, versus those who are more supportive of an incremental jump towards 182 millimeters as less risky. What are your thoughts on this? I guess that I can first kick this over to Hongbin.
Yeah, I think our view is that it's not bigger, it's not always better, right? So when we design this 182 millimeter, when we roll out this 182 millimeter M10 wafer standard, and we going through the whole analysis of the whole manufacturing process, as well as the deployment process, right? So we look at the ingot, wafer, cell, and module manufacturing, as well as shipping, handling, installation, right? And so this 182 is come up, going through the whole process, realize one of the main constraints actually is doing the shipping, right? 40-foot container, the opening size is 2570, right? And that comes down with the current BKM, the best known method for shipping the modules. If you lay the modules vertically in the landscape, right, within the pallet, and then double stack the pallet inside the container. That with that limitation, actually that limit the module size to be 1130 millimeter, and then which translate into 182 millimeter, right? When we have, if you need to make a larger size wafer within the module, you can make the module wider, but you will not be able to follow that BKM anymore, right? You can compromise on the shipping quality, the potential damage during the shipping. That's one of the areas that larger size module may incur higher risk, right? And the other factors, for example, with the 210 millimeter wafer, the current, right, of the module running is more than 18 amp, right? So you need to increase the fuse sizes, and then the junction box need to be totally redesigned, which incur additional risk. So what we are saying here, basically, with a changing from M2 to M6 and now to M10, you see that BOS saving, you can expect the BOS savings, but that level of saving actually gradually getting smaller, right? And in the meantime, if you go even larger, that risk associated with the larger size modules are getting larger, right? And the other aspect is actually on the manufacturing cost. And as if you need to use the larger size wafers, keep going, beyond 182, you may need to increase the thickness of the wafer, which translates into a higher cost, right? So I think the 182 is what we think is probably is an optimal position where you can, balance the benefit with the cost versus the risk, right? So okay. That's what we think, where, that's why we decided 182 is the right size for the next generation of modules.
And Thomas, I would like to bring in your perspective on this. What's Canadians' position of wafer size, and what are your thoughts?
So first of all, I would like to see it from a customer perspective. Mm-hmm. So technically, I believe a customer doesn't care what size of wafer you're using. You're looking at a full product with a certain efficiency, certain performance, and certain price, okay? So if we are able to produce something with a certain spec and outcome, independent what size we're using, then in principle, customer, the system should be happy. But then comes, of course, the manufacturing cost overlay, the manufacturability overlay, and of course, as we have mentioned a couple of times, the quality overlay. Our thought was, if we can manage it with certain formats, what is the biggest benefit we can produce and to deliver versus the quality balance? That's where Longyi's and CSI's opinions are different. We have done similar simulations and optimizations, and we believe the biggest value increase is stepping right into the 10mm base because it's manageable. The wafer is not thicker. We even have further optimizations on the manufacturing machines and equipment, on the stringing, etc. So it has a lot of manufacturing-related optimizations and positive impacts. Again, on the flip side, you could produce a 660-watt panel, which we're coming out with a 166mm format. For the customer, it doesn't really change a lot. But on the flip side, also within the panels with the larger formats, we have less interconnections, less bus bars, less soldering patterns, maybe less soldering problems. So it goes both ways. But the key point is you need to have a quality manufacturer, somebody with a significant experience, with the R&D capacity and the capability behind, the testing capability behind, working with re-owned third-party engineering and testing companies like CA and others, because we need to convince financiers, investors and others, not only for the 210mm format, also for the 182. It's a new product, it's a new format. We need to convince the industry. We need to work together with inverter and tracker manufacturers to have the system ready. And of course, the balance of system manufacturers being ready. But we have done it before. We have seen that many, many times. So we're neither scared nor worried about, as my friend from Scholl said, it's happening as we speak.
Yeah, I agree with Thomas. And actually, I have a quick follow-up regarding the wafer or solar cell size. So actually, when I was writing a research note about solar glass, I had a check of all the available products from the large manufacturers and found that a solar module containing 182 wafers can be larger than a module containing 210, simply by using more pieces in the same module. So if that is the case, this is for Hongbin and Thomas, do you think it will be the solar cell cost that makes the final decision who will win? Because no matter it's 180 or 210, they can be assembled into the same size by adjusting the piece count.
Yeah, so let me take a first cut. Yeah, thank you. So I think this is all, from a customer perspective, you need to look at the whole, the total cost of, module deployment of the system, right? That's what determines the value to our customers, right? So that including the module manufacturing cost as well as the deployment cost, right? It's the BOS and installations. And from that perspective, that you need to look at and also the other aspect as the thing, other people mentioned is the risk, right? It's the reliability risk, right? And so I think if you look at all these things together, the module manufacturing cost, including the module manufacturing cost itself, including both the ingot, wafer, cell, and the module manufacturing, right? And the solar cell part is a small portion. Actually, if you look at the overall total cost, solar cell manufacturing cost by increasing the throughput with the larger size wafers, that may have some impact. But if you look at the overall, even the module cost itself, a majority of the cost actually associated with the raw material cost, right? The frame, the glass, which actually does not scale, which the size is going to scale with a wafer size, But it does not improve unless the efficiency of the module is improved, right? So in that sense, going larger is not saving on the material average per area material cost. That's why, when you go to larger, you may need to have a stronger frame, right? Maybe a thicker glass. Those can maybe work against you if you go over, right? So that's on the module cost itself. And the deployment part, I think it is related to like logistic costs as well, right? You look at whether that the shipping method has a minimal risk associated. And also the other aspect will be the associated risk on like a hotspot junction box. Those because of the much higher current going to incur with the 210 millimeter wafers. You're going to have ISC is more than 18 amp, and the fuse need to be like a 30, 35, or even 40 amp to be able to handle these large size modules. These are all associated, risk. I think that it will take some effort for the industry to work them out.
And I do want to jump in the conversation here. I do want to, George, I want to bring you up onto the screen as well and bring you into this dialogue. There's obviously some quality risks associated with this and challenges. What is CEA's perspective on not only moving to bigger module formats, but also higher efficiency at the same time?
First of all, thank you for having me together with these top experts and manufacturers. The changes that have happened in the last year are really mind-boggling. I haven't seen anything like that happening in the 10 years I've been in solar, and certainly not before that. And it's not just, we say big modules, but it's not just about big modules. There are other things that are happening, like the dense interconnection technologies. That's a term we like to use, which is really things like paving or even tiling and shingling. So there are certain quality risks here because the distance between the cells is reduced. This can be really big. We see manufacturers that have chosen going towards one certain technology, doing a somersault in the middle and going towards another because the manufacturability didn't work like it was planned. And the numbers are huge. So the top 2 manufacturers will have around 30 gigawatts this year. These are really, really, really big numbers, okay? And so things have to be done properly. But the speed of the change is really very worrying. Now, as Dean said in a conversation recently, we're jumping over the cliff and we have to do it because that's solar. That's how we do it. So let's make sure we do it in the right way. And there is a methodology. That's the good news. So all these are really big risks. I mean, it's really a very long list, okay? But there is a methodology. There is a way to solve this. We have the extended reliability testing. The designs, the module designs have to be qualified. The production lines have to be audited. All these things are happening as we're talking, but they're not over yet. So they have to be done. I guess in 1 year from now, everybody will be a lot more confident. Certainly, in our view and our interactions with our clients, the market is jumping on the big modules because they're bigger. So just the power of a single module makes a big difference. Also, they're more efficient because of the other chains, okay? The density connection, which are equally important. So these are really very good things. The LCOE is going down fast. Also, they're cheaper. Maybe not now, but we're gonna see it maybe in a year. Yeah, there has to be some depreciation of the upgrades that are happening right now. But definitely they're a lot cheaper. I've seen like some calculations we're doing ourselves, maybe 1 to 2 cents from M1, sorry, so from M2 as a baseline, G1, sorry. So this is really big, okay? There's a lot of money to be made and a lot of money to be saved. But we have to do things in the proper role and not rush things ahead. So we don't like to see deals being signed up without any third-party extended stress testing being finished without like the basic steps being taken. This is what we don't want to see. If we do things in the right way, it's gonna be fine next year.
it seems like there's consensus. So LCO is coming down. There's implications and adjustments that need to be made, but it's also happening quickly. And I guess what I'd like to do is, before we get to Q&A, I'm sure we have a really active audience right now. I would like to ask each of you to just maybe 1 minute of how do we ensure that this transition to large format modules is done with the most reliability. I'd like to go ahead and pass it off to you first, Thomas, and then we'll go across.
Thank you. So I just wanted to follow up to what my colleague from CEA said. I think timing is essential, and everything which has been said so far connects to each other. From how do I load a container? How do I unload? Do I have reliability testing done? Has the factories been inspected? So it's a process which does not relate to the pure module design and engineering and manufacturing anymore. It's a complete value chain and market chain. That's why, in order to fulfill, to complete, test, have the reports available, communicate to customers, banks, etc., we are launching the 665 watt panel size by May, June next year, because it's a timing, positioning to have everything in place and everything done, so that companies like Scholz and others can catch up and the systems are really readily available. Of course, we have to communicate early on so people can adjust the designs and to adopt the designs. But it already has a target date in sight where the things all fall together and come together. So I've said, yeah, we're jumping off a cliff, but thank God we have a parachute on our back.
And Dean?
Well, since we're all about optimism here, how about I throw out to the module people that, hell, while we're making large format change, why don't we make a voltage change and go from 1500 to 2000 while we're throwing this into the mix? Talk about helping the system cost would be a voltage change. Food for thought. But other than that, a lot of us have been working on these topics, quite honestly, in the background for a long time. So it's not like you're going to have a lot of products that were just thrown to the market haphazardly and no one's really ready. But one of the things we stress is reliability of the power plant. Make sure we've got all the fuses and the fuse holders and all the boxes that are taking these increased currents to make sure they're reliable, because nobody will. You could be the best, most profitable company in the world. Once you have warranty claims, life sucks fast. So just everybody, when bringing systems to the market, make sure modules are good, the EPOS is good, the trackers, and again, nobody's really talked about the inverter players in the game, and they've got to increase that input. And as we've seen lately, inverters, when they fail miserably. So we got to make sure everybody gets this right on the launch. But as I've said earlier in the show, we in this discussion is when we walk to the edge of the cliff, we jump and we're not sure if there's water or glass at the bottom. But either way, let's go and hurry up and get it done. That's how innovation occurs.
And Colin, what are your thoughts on this?
Well, I mean, from the tracker perspective, the most obvious thing to point to, of course, is the wind design and wind tunnel testing, right? There's just no replacement for having experts in the field, having run your system, specifically your design with your dimensions and everything, through their wind tunnel test. And moreover, peer reviews, right? Like to have more than one set of professional eyes on that. Not only will that give everybody the confidence that they need to sign off on the equipment, but it will also allow the manufacturers to, optimize as best as possible for a given set of scenarios or for a given plant. So I really can't stress that enough, as somebody that has seen what can go wrong if, this type of thing is not paid attention to, or, some of the immaturities of the market that we had seen in the past. As the modules get bigger and heavier, this is again going to be a major focus, and just can't stress it enough that wind tunnel testing needs to be performed by industry experts.
Thank you for that. And then I'm going a little bit over time, but Hongbin, I'd like to ask you as well what your thoughts are as far as doing this in the most reliable way as we transition to a larger module future.
Okay, yeah, definitely. I think I just want to make clear that the larger size modules are really the most savings actually on the BOS, right? That's where the most value is coming from. And so definitely there are a lot of homework that we need to do on both module reliability as well as the overall system reliability, right? That's the part. There are a lot of homework that we need to do from a manufacturer perspective, as well as working with the downstream players like a tracker, inverters, and then electric component, right? Manufacturers make sure we have a reliable solution, right? Like a fuses, junction boxes, and minimize like a hotspot risk, right, associated with the larger size modules. And so I think as we see, this is the size conversations. I think probably going to settle pretty soon, right? I think the next thing we need to look for probably is the efficiency improvement. That's mostly, the further cost down will be realized is through efficiency, both cell efficiency and the module efficiency improvement that can help to bring us more values, to the whole system, to our customers.
Okay, great. Thank you. Thanks, guys. This has been a really engaging and lively discussion so far, and a special thank you to Xiaoting and Bloomberg NEF for taking an active role in this dialogue today. Xiaoting will also stay online to answer questions from you, our viewers. Please feel free to continue to submit, but I'd like to go ahead and bring Marian back, who's been managing the Q&A throughout this process. We'll be right back.
Thank you.
Okay, Marian, thanks for joining. Can you go ahead and give me the lowdown? How are things looking with the questions that we've got so far?
Very good, very good. Our online community has been very active over the last session, over this panel, and they have been posting their questions. And I do remind you, you can still post your questions, so upvote those of others, post your own, and we'll get through them. I will kick the first one to Xiaoting, since you're here and you're staying around for questions. In your opening keynote earlier, you mentioned perovskite modules, and of course, we in the solar industry were always looking for when is the material stable, when is it market ready. What gave you indication that this technology will be entering the mainstream within the next 10 years?
Yeah, actually, I can share the title of the research note I wrote about perovskite, which is not so optimistic for the investor. That is perovskite, not a game changer for the next 5 years. So basically, that is a conclusion after I checked the progress in both academy and industry. Although there are probably 4 to 5 companies in the process of commercialization, I personally don't think they will form material impact to the industry in terms of total shipment volumes. It's very hard for developers or EPC companies to take several like tens megawatt, not to mention 100 megawatts, because the reliability issue, although there are continuous reports about better improvements for the reliability, but the fact is there lacks very fundamental standards to prove that it can hold like 20, 30 years in outdoor operation. So it could be very misleading to use the same standards for silicon PV modules for perovskite modules. So that is for the cautious part. And the reason why I see it has a high chance to play a role after like 2030 is basically when I look at the fundamental like features of the material from both physical and electrical features. There is no like such a point that would stop the progress of this material to become more mature and being able to like apply it in the industry.
Thank you. And at the beginning of this program today, our first session was focused on building for resiliency, and we see there's more hailstorm damages that have been coming through with modules in the United States as as extreme weather events are increasing. And the next question is surrounding how resilient are these modules? There's been concerns brought up of glass not getting thicker with the module size. Are they becoming more flimsy, or what can we expect?
I'll shoot this question to George, maybe.
Thank you.
Yeah, he would be in a good position to answer that.
Yeah, thank you. So there are 2 things. One is the mechanical strength that is directly linked to the size. Okay, so you really have to do your testing, your static, and the DML, of course. dynamic mechanical loading, and the other is the thickness of the glass, so the impact strength. And this is not really related so much to big modules as to thin glass modules. They have to be thin because they're double glass bifacial mostly, and the standard glass thickness is 2 millimeter nowadays. So there is a region in the US, in the middle, big parts in Texas as well, where we have really extreme hail events. And these 2 millimeter thick modules cannot really withstand such big impact. So this is a big headache right now. The insurance companies don't know how to deal with it. Well, you know, they increase the premiums and put a cap, but that's not workable. And we're actually in CA, we're involved working with insurers and undertaking advisors and some test labs that are developing new standards for hail durability to find a solution on this problem, because, you know, the projects have to be built. And right now there is only a thin film solution that satisfies, let's say, checks all the boxes. So that's just an example of the problems that we have with natural phenomena.
Thank you, George. I really like your background, by the way. Now,
I don't know. Look at Dean. He's got Mickey Mouse.
This is the running joke of 2020. Now, I have a question for Colin regarding the larger form factor modules and obviously the implications for that for tracker suppliers. You mentioned earlier that wind tunnel testing needs to be revised as the form factor is increasing. Can you give us an idea of your findings so far? From which point on, how much does it have the module to increase? So you have to add more steel to the structure or actually revise the wind damage mitigation strategy altogether?
Yeah, so I mean, there's a couple of things to consider. I mean, the damage mitigation strategy, there is a stow strategy that we've, let's say, reassessed, right, in recent years with results from wind tunnel tests from small format modules up to large format modules. And in most all cases, it's going to be most advisable to do a high tilt stow strategy, where you basically have a first line of defense that is protecting downwind modules. And with that said, there's increased static loads that are on the system. So there's just been a transfer of where some of the steel was allocated from how a tracker performed or would behave in the past with a lower tilt angle versus the higher tilt. And so what we're finding is that maybe the purlins have a little bit more strength to them. The torque tubes can get away with actually being thinner profile, and then the piles, there may be additional piles, or in our case, we've even looked at synchronizing our gearboxes and our drive lines. So different ways that we can continue to have a really reliable, robust system and then still allow for longer trackers so that we can accommodate at least 4 strings, but we're looking at even 6 strings and do so safely. Then, of course, there's the behavior downwind and where we can have efficiencies on having interior trackers that are going to be utilizing thinner profiles so as to pass those savings on to the buyer. There's another point that I just wanted to kind of piggyback on from earlier speaking about hail, because it's not only the modules that can, let's say, offer the customers a mitigation strategy for that type of things, because trackers really can too. You know, being that the high wind strategy, as I was mentioning, is a higher tilt angle, that's something that most often is going to be a good strategy for avoiding damage for hail too, simply because when hail is going to be falling from the sky, it's going to be less likely to cause damage if the tracker is left at a high tilt angle. So the combination of weather prediction software and, let's say, precipitation detection hardware on a site can allow us to have that type of capability.
Colin, let's catch up. We're working on that, actually.
There was, I guess the biggest comment that's come in is surrounding labor costs and installation costs. Potentially there being this being higher, or concern of this with higher weighted modules. And I know, I mean, just thinking about installing these things hurts my back. What are we thinking, or how are we taking the downstream market into consideration as far as, you know, we're saying that the costs will be coming down as far as installation is concerned, but these are obviously much larger formats. what will the implications be with installers? And Thomas, I'll go ahead and put that over to you.
Okay, thank you. So as you know, Canadian Solar is not only one of the largest module manufacturers globally and other components. We also have a world-leading development team, and we've installed so far multi-gigawatts of projects ourselves or for third-party customer. What we're seeing right now in our real-life activities and tests, that the installation crews, which are currently out on the site, a certain team, a certain crew does not do the same job all day long, all over again. So already today, the crews are switching locations, they're switching positions, they're switching tasks. So in order to mitigate, for example, the larger formats and the higher weight, the teams are swapping out activities a bit faster, a bit earlier. So it's basically an installation crew process adjustment towards these higher loads. They're heavy. We need to protect our people and the workers on site and not to expose them too much. Absolutely right.
Okay. Good.
I'll pick up on a note that George mentioned earlier. There's different intercell stringing that manufacturers are deploying. There's tiling and paving and shingling, as you mentioned. A question to Hongbing at this stage. Do you see any difference in efficiency, and which are, to your experience, the best intercell stringing methodologies that you have seen in this space?
Yeah, I think in the last few years, there are a few technologies that try to help on the module side, right, to improve the efficiency. First is half cut, right, and then comes down. Recently started multi-bus bar, right, multi MBB solutions. You know, you have 9, 10, 11, 12 different, bus bar width. And then also there's a tweak on the cell space, right? Recently in the last couple of years, and we have experiencing, we have been testing different strategies in terms of small spacing, reduce the spacing between the cells, so basically increase the packing density, right? So we have explored a few different options, and then comes out. I think this is this is the micro gap, like a 0.5, 0.6 millimeter, right? Instead of reduced from the original 2 millimeter. That seems to be a good compromise in terms of manufacturability and also the module efficiency versus the cost. Right, so that seems to be a sweet spot that you can get maybe the best of all the combinations, right? And with a smaller reduced cell gap instead of going to a negative, cell gap.
All right, thank you, Hongbing. I'll shoot one last question over to Dean at this stage. You earlier mentioned a proposal for a 2,000 volt technology. Is this a serious proposal? Are you in actual talks with power electronics suppliers?
Well, actually, the module would have to increase in voltage, have the right creepage and clearance, but it would be a switch to connectors and wiring and inverters. But it's the natural progression that should happen. You go up another 500 volts on that string. The strings will decrease in size, efficiency, and how the stringing happens will be much better. You'll have much longer tracker rows with smaller gauge wires, which all adds to the efficiency, and it would ultimately take labor out of the installation. So I can't say I'm not working on that solution.
Can I give a comment very quickly on the 2,000 volt? Because I heard from industry insiders that there is exploration program ongoing in China already, and this program is led by a large developer, is a state-owned enterprise. And both LONGi and Sungrow are involved in that project to see what kind of material change or structure change will be needed to make their products compatible with the 2,000 volt system.
Wow. Wow. Well, I think that this actually wraps up the session really greatly. I want to thank our panelists so much and our audience for your involvement and participation today. This has been a really interesting dialogue, and I think we're at a very exciting time for the industry. My biggest takeaway is obviously we need to do this in a responsible manner, but it's costs are coming down, efficiency's going up, and there's a lot to be excited about within our industry right now. So thank you again for joining us today.
Thank you for having us.
Bye.
Thank you, industry.
Have a beautiful rest of your day. Thank you. Okay, and with the new president-elect, the future also looks bright. Up next, final remarks from what our industry can expect with a look at what's on the horizon for the clean energy in the next 4 years. Needless to say, it's been one hell of a year. We're closing out one decade and moving anew with changes in the White House and DC quickly approaching. Clean Energy for Biden started out as a campaign organization that raised more than $3 million during the elections and has evolved to become an organization with more than 10,000 members across the industry. The work of the organization is really just getting started, and the Clean Energy Plan has yet to be deployed. Joining us today and closing out our program is Cameron Bard, who works in the solar PV industry and teaches public policy in New York, but he is also the co-chair and founder of Clean Energy for Biden. I'm going to go ahead and bring you in. Hello, Cameron.
Hey, Erica, how are you today?
Hi, doing well. My feet are starting to hurt, but we're doing great. It's been a wonderful day, and there's lots to be excited about within the industry.
Sounds good. Well, it's great to be with you.
Thank you so much for joining us. So what can we expect over the next 4 years?
Sure. Well, first of all, thank you so much for having me. I'm coming to you live from Southern California. As you can see, there's beautiful weather behind me. It's been a little bit hot this year. The wildfires have been rampaging across our country, and there's really no greater time for us to look forward to President-elect Joe Biden's administration coming in. I've been a longtime reader of PV Magazine, so I'm thrilled to join this group. I know that today has really focused on advanced technologies and some of the technical components of our industry, but I'm hoping to chat a bit with you here at the end during these closing remarks on the political matters facing us as an industry, and really, as I see it, a tremendous opportunity in front of us. Eric, as you mentioned, my name is Cameron Bard. I serve as one of the founding national co-chairs of Clean Energy for Biden. And I've been working on this campaign for the past 7 or so months with literally thousands of other colleagues throughout this country representing all 50 states to do one thing. And I'm proud to say we accomplished that one thing, and that was to elect Joe Biden as our next president. I've worked in this industry for a number of years. Before serving in the private sector, I actually worked in Governor Cuomo's administration back in New York, where we helped to stand up multi-billion-dollar programs for solar and really address and lead on climate change. Over the last 4 years, we've seen states and subnationals step in where the federal government really abdicated their responsibility, moving away from leadership on climate change, dropping out of the Paris Agreement, and really letting the American economy return to some of our traditional fossil fuel energy resources. And as I mentioned, every single day, the Earth gets hotter, and we start to see the effects of climate change more and more, whether it's in the form of increased frequency and intensity of hurricanes, wildfire seasons that literally go beyond the season and now last entire years, or a number of the other myriad effects that are facing communities throughout this world. So when I think about our role as an industry, I get really excited about what a Joe Biden administration can do for us. And as much as we've talked about the technological and the technical opportunities and challenges facing our industry, it's important for us to remember that we exist in a world where politics really do matter. And our industry has long ignored those opportunities. And we've really ceded a lot of ground and a lot of the oxygen in the rooms on Capitol Hill and elsewhere throughout this country to our counterparts in other industries. And this isn't about direct head-to-head competition with oil, gas, and coal, but it is about making sure our voices are heard and we have and can leave our fingerprints on new policy that is ushered in by Congress and by now our President-elect Joe Biden, his Vice President-elect Kamala Harris. So a little bit more about Clean Energy for Biden. As I mentioned, we launched about 7 months ago on Earth Day. We actually did an event with Joe Biden himself, where he talked about his long-standing commitment to environmentalism and his excitement about clean energy and the clean economy. Really, after that Earth Day event, we've been able to grow our network to over 11,000 members throughout this country, as I said, representing all 50 states. So those 11,000 members come from solar, they come from wind, energy efficiency, electric vehicles, and so many other clean technologies throughout this country. It also includes climate advocates, engineers, lawyers, wind technicians, you name it. folks who are in this industry, folks who want to get into the industry, and it really represents a grassroots movement to do so much more when it comes to our clean economy. And when I think about the success that we've had with CE4B, whether it's growing our network to over 11,000 members, raising over $3.2 million for the Biden campaign, or hosting literally hundreds and hundreds of events with leaders such as former EPA Administrator Lisa Jackson, Mayor Pete Buttigieg, Governor Jay Inslee, Governor Michelle Lujan Grisham, and so many more, I am also equally excited about the movement we are building and the continued progress we can make when it comes to politics and helping to shape these new bills and these new laws that will greatly impact us. As you've heard today from the innovators leading the charge on the technical side of our industry, there's a lot to be hopeful for. But if we simply sit back and let our innovations and our technology and our breakthroughs lead the day, we will forever be in second place to others who are spending literally hundreds of millions of dollars more than us every year in campaign cycles. In fact, in 2018 midterm cycle, oil, gas, and coal spent 13-1 dollars in terms of fundraising and other opportunities to elect fossil fuel friendly leaders compared to renewable energy industry. So every dollar we spent within renewables and clean energy, fossil fuel spent $13. That ratio has got to tip if we're serious. And so when I think about the transition of clean energy for Biden and the opportunity created by the Biden administration, I am so optimistic about what we can accomplish together. So what does President-elect Joe Biden stand for? Well, he's made clear that his administration will be the foremost leader on climate change that we have ever seen in the White House. You know, he's committed nearly $2 trillion in spending and investment into this area of the economy. He's set highly ambitious global leading goals to lead to a completely net zero economy by 2050. He wants to move entirely away from fossil fuels when it comes to our power grid, starting in 2035. And equally exciting and very much more important, he wants to deliver these benefits, deliver these investments into historically underserved communities, areas that are dealing with high asthma rates, frontline communities that are facing the effects of climate change far more than other communities with greater wealth and greater access to control and power. So when we look at that opportunity within a Biden administration, we as an industry have got to unify together. We have to move away from trade groups battling with each other. We have to move away from technologies viewing others as competitors. We have to work together, because if we don't, as I mentioned, we will always be number two to others who are out there clinging to their incumbency and trying to raise the barriers of entry to these industries. So we as an industry have to unify in order to fully realize the opportunities created by a Biden administration. And I think we can do that. And we've already seen tremendous progress with clean energy for Biden, with wind and solar working hand in hand to raise literally millions of dollars for candidates. And now as we pivot and start to focus on the Georgia Senate runoff, we're seeing that same collaboration and cooperation. So an enormous opportunity presented by the Biden administration, a dramatic need for us as an industry to unify and work together and tip that ratio from 13-1 fossil fuel spending to renewables, turn it around, go 180 degrees so that we actually are the ones who are spending and investing in our leaders and ultimately in our government to hold them accountable and to help, as I said, shape those policies to drive our industry forward. And then lastly, I really want to drive home the need for us as an industry to prioritize environmental justice, diversity, and inclusion. You know, when we think about the effects and ramifications of unfettered markets pushing off externalities that have led to climate change to begin with, that have led to environmental injustice, that have led to neighborhoods like the South Bronx having asthma rates far higher than the rest of New York City, it's the lack of regulation and it's the lack of attention, focus, and prioritization that has caused these absolutely unacceptable forms of systemic racism and environmental injustice. And we as an industry have to recognize that and be a part of the solution, no longer a part of the problem. And I'm really excited to see that in the Biden climate plan, they specifically call out not just that total $1.7 trillion investment, but a commitment to ensure 40% of total benefits of that spending are delivered to communities of color and communities that have been historically underrepresented in our government, in our economy. So as an industry, we need to make sure we drive those same benefits into the communities we are serving. We cannot simply stand back and treat those communities as second in line to where it might be easier or cheaper to install our resources. So what I want to leave you with is optimism about the Biden administration, a commitment to unify, and a prioritization of environmental justice, diversity, and inclusion. I couldn't be more excited about what's in store for us, coupling the innovation and the technological breakthroughs that so many attending these roundtables are leading with our newfound willingness and interest to double down on politics and to roll up our sleeves and compete. I'm really, really hopeful for what's ahead. Thank you so much for having me, and thank you so much for joining today's call.
All right, thank you, Cameron, for these words today. I always have actually thought of, you know, when you bring up 13 to 1, I've sort of thought of solar PV and, you know, the fossil fuel industry being more of a story of David and Goliath. And so do you think there's also an opportunity now for moving ahead for the industry to work together in a more collaborative approach with the numbers that have already been achieved moving into these next 4 years surrounding the clean energy plan as well?
Yeah, absolutely. I mean, we've seen incumbents pivot already. You have, you know, major announcements and headlines being made by folks like BP investing in new technologies on the clean energy side. You have NextEra now, which is a larger by market cap company than Exxon, that are really delivering in this space. So, you know, when I think about that 13 to 1 ratio, the 13 doesn't need to be achieved within our David, if you will, companies. We can also pull those investments away and have the very same companies pushing forward fossil fuels reinvest in a cleaner, more equitable economy as well.
Yeah, great, great. Well, thank you for this. I'm really excited, looking forward into the future of what might be in store for, with us being so tied to policy and regulation, the future is looking bright. And thank you again for all the work that you've done and for being a part of this and closing out our session today. We'll look forward
Absolutely.
To
Thanks so much for having me, Erica.
All right, take care. Well, ladies and gentlemen, this has been an eventful and very informative day for us here at PV Magazine. Really exciting. You know, 2020 has been a year of significant change and challenge for the United States. But despite this, the PV industry has not only remained resilient in the face of obstacles, but I really believe that we have thrived, and we're stepping into an advanced technology future with a lot of new things on the horizon, despite the challenges that exist. So stepping up to this challenge, our industry is really advancing the country into the next era, which seems to be a decarbonized one. So thank you to everyone that has joined us today for taking a part of a program. It's been absolutely stacked, and we hope that you've enjoyed all of the content that we've brought in. And thank you again to our experts and our partners.
But it's not quite over yet. How about a spot of networking, or why not meeting our speakers from this advanced technology session and engage with the rest of the industry over the next hour or so? We do have Bernadette Del Chiaro still in the Meet the Speaker Zoom room, which will take place here on the main stage. Also with her is Bory Akyol and Ian Gregory, Honbing Fang, and Thomas Körner will also be around to answer your questions regarding the topics that they have discussed earlier. We have this set us up all for you and your company to gain the knowledge and make good business connections to thrive forwards into not just the next 4 years, but also the next decade. And we do have, I'm told we can announce our winners of our scavenger hunt and our raffle. They will certainly thrive into the next 4 years. Well, that's Fabian Desu. No, that's Ikai Onye Maobi making the 3rd place. Congratulations to you. And we have Fabian Daozu on 2nd place. And the winner is Stelian Miriaki. Mirika. Congratulations to you, and thank you for participating in our games here during our roundtable event. it was an absolute pleasure. Please do let us know whether you also thought it was an absolute pleasure in the survey that will pop up shortly, and we will enjoy and appreciate your feedback on this session. Also, we at PV Magazine, all of us, wish you a very happy Thanksgiving and holiday season, and we look forward to seeing you again next year. May that be in person or online still.
Hopefully in 3D. Yes, now it's time to network. Thank you again. Thank you to our partners, DuPont, Trimark Associates, for making this all possible. And we wish you all a very happy holiday season.
Goodbye.
Bye.